Hi, it's Teacher RJ, and welcome on our day two of online learning. Have you noticed a moisture just outside your cold drinking glass? How about the water droplets on the leaves every morning? Everything seems very wet every morning, if you notice that. And how do clouds form? Where are they? Where do they come from? In today's lesson, we're going to understand those things. We're going to focus on condensation, how clouds form, how everything seems to be very wet in the morning, and where do those water droplets forming outside of your cold drinks come from. At the end of this lesson, I want everyone to be able to first describe the changes of state during condensation. Second, recognize that a change in state from gas to liquid can occur when water vapor loses heat. And third, state the factor or factors that affect the rate of condensation process. Before we go through that, let's remember what we learned in last meeting. We learned that when solid gains heat from its surrounding, it will turn and change state into liquid. That process is called melting. At the same time, when a liquid state loses heat to its surrounding, it will turn its state and become ice. That process is called freezing. So melting and freezing, where the change of state is caused when there is a transfer of heat. We also learned that at 0 degrees Celsius, water freezes and ice melts. 0 degrees Celsius is the freezing point and the melting point of pure water. Pure water. That is if it's a pure water. Impurities and addition of other substances in pure water can cause or can change these freezing and melting points of the water. Salt, for example, when added into ice, can cause its melting point to go as low as -3. So instead of melting at 0 degrees Celsius, it now needs -3 to melt. So at 0 degrees Celsius, ice will now melt faster because it starts -3. At -2 or -1, ice will start to melt with the presence of salt. And if you have a liquid water with additional salt or a salt water, then that water will no longer freeze at 0 degrees Celsius. It will now need -3 degrees Celsius for that liquid to turn into solid. So again, impurities or salt, for example, in particular, can change freezing and melting point of the ice. Today, our focus is about condensation. What is condensation? Condensation is a process of change from gaseous state to liquid state. When gas change to water, that is called condensation. How does that happen? That happens when the water vapor in the air loses heat. So the water vapor contains more heat than water. So when that extra heat is lost, water vapor will move slower, come together, and form water droplets. The formation of water droplets from the surrounding air or from the water vapor in the surrounding air is called condensation process. Again, condensation is a process of change from gaseous state to liquid state. And that happens when gas or water vapor loses heat. When gas or water vapor loses heat, they move slower, come together, form water droplets. So change of state from gas to liquid is caused by losing heat or heat loss. Now we observe this phenomenon plenty of time, almost every day. If you pull out cold drinks out of the fridge, you will observe the formation of these water droplets outside of the container. Now, where do these water droplets come from? Not from inside, not from the water in the container. That is very clear on this example here. This can of drink, for example, is sealed. So it's very possible that the water droplet is coming from the inside of the can. So where are these water droplets coming from? We learned in previous chapter that air composed of many different types of gases, and that includes water vapor. There is about less than 1% in our air that is made up of water vapor. Now, these water vapor contains a lot of heat. As they touch this cold container or the surfaces of the cold container, like a cold can, a cold plastic, or a cold glass, the water vapor around it will lose heat, come together, and slowly form water droplets. And that's how these water droplets form outside of the container. Again, these water droplets comes from the surrounding air. Let's learn more. Now, condensation happens when there's a difference in temperature between air and the other object. So condensation happens most of the time with warmer air. Warmer air condenses and forms into water droplets. It is the warmer air that contains and possesses a lot of heat. It is the warmer air that loses heat to a cold surface, glass, for example. So if the glass is cooler than the warmer, either than the air around it, then that air can lose its heat to the glass. If that happens, that air, warm air, cools down. As warm air cools down, it will gradually come together, slows down, and form water droplets. Now, I wanted to observe how these water droplets form on the window. What do you notice? You will notice that the water droplets form inside the house or inside the room. A lot of water, tiny water droplets, or even bigger water droplets form inside the house. What does it mean? That means that the air inside the house is warmer compared to the glass and the outside environment. If that happens, the warm air inside the room touches the cold surface of the glass, loses its heat to the glass, and forms water droplets. You might not observe water droplets on the other side of the window because, again, it is the warmer air loses heat and condenses. So condensation happens on the warmer side, not in the cooler side. It happens maybe if you're experiencing winter or if it rains outside and the temperature outside is cooler compared to the room temperature. So again, if that happens, the warmer air inside the room can touch the cooler surface of the window, lose its heat, slow down, and gradually form water droplets. That is condensation. Now, this one is another example of condensation. The driver is driving in a rainy day. Now, notice that even if the driver turned the wipers on, it's still foggy. The windshield is still foggy. It's still not very clear. Now, where do you think the fogs are forming? Is it inside or outside the air? If you notice, if it doesn't clear out, even if the wipers are on, that means the water vapor or the condensation happens inside of the glass. What does it tell us? That also tells us that the outside temperature is cooler compared to the temperature inside the car. Again, warmer air cools down and condenses. So in this case, for example, if the outside temperature is cooler, then the air inside the car is warmer. Now that warm air touches the cold surface of the windshield, loses heat, cools down, and condenses, forming tiny water droplets. Another example is if you see freshly cut food. Now, if you look on the lid of the freshly cooked food, you will notice a lot of water droplets forming in the inside of the lid, not on the outside. Why is that? Even at room temperature, if the air inside the pot is way warmer than the room temperature, then the other side will be cooler. So if that happens, those warm air or water vapor inside the pot will lose heat to the cooler side or to the cooler let or lead, let, and then slows down and forms water vapor. That's the reason why we'll see moisture on the lead of the freshly cooked food. That is caused by condensation. Again, it tells us that the air inside the pot is warmer than the outside. And that's why condensation happens in the inside and not on the outside. Dew. Now, we seldom notice and observe dew every morning. Now, everything seems wet if you go out early in the morning um, before sunrise or just sunrise or during sunrise. If you touch the grasses or the leaves, it seems wet. Now, where do those water come from, even if it didn't rain? Now, those water droplets actually do not come from rain. Those water droplets actually come from the warm air during the day. Now, during the day, the air is very warm. As the sun sets, the environment or the surrounding temperature cools down. As it cools down, that warm air during the day will will lose heat to its surroundings, such as leaves or plants or ground. When that happens, again, they will slow down, crumble together, and form tiny water droplets. So that's how dew forms, the condensation during the night. So again, dew or those water droplets on plants every morning are actually coming from the warmer air during the day, cools down and condenses at night. Clouds. When water vapor during the day goes up in the sky, they cool down as they reach high above the sky. As they cool down, the same process, they will slow down, come together, and form tiny water droplets. Those water droplets come together and form clouds. So clouds are actually just water droplets coming together. So warmer air goes up during the day or even night time or any time of the day, and then cools down as it reaches the highest part of the sky or the coolest part or cooler part of the sky, then condenses. Next question. Do water vapor condenses at the same speed? Probably not. There are two factors that affect the condensation rate, or the rate of condensation, or how fast condensation occurs or forms. First one is the temperature. The second one is the amount of water vapor in the air. Let's talk about the first one. If you have an ice water, where do you think the condensation will occur faster? Is it when you place the glass of water near the window or inside the fridge? If you place the ice water in the fridge, the difference in the temperature will be that what will be that different. So if that happens, the condensation is very slow. Condensation will still happen because there's a difference between the two, as the water could probably have 0 degrees Celsius and the fridge has 3 degrees Celsius or 5 degrees Celsius. So with a difference in the temperature, the warmer air will lose heat to the cooler surface, and then condensation happens. But if you place ice water near the window, which has room temperature, or the temperature which is about 30 degrees Celsius, then that's a big difference. Imagine you have 0 degrees Celsius and 30 degrees Celsius. That means the surrounding air closer to the window is way warmer. If that happens, a lot of these air will lose heat faster to the cooler surface of the ice water or the glass where ice water is. So if that happens, more and more warmer air loses heat and form water droplets. So again, when there's a big difference in the temperature, then condensation occurs very fast or faster. The rate of condensation is faster when there is a wide gap in their temperature. Next one, amount of water vapor in the air. We learned that condensation is about water vapor losing their heat to the surface. So that means we depend on the amount of water vapor. Condensation depends on the amount of water vapor. If there are a lot of water vapor in the surrounding air, then a lot of these air can lose heat and form water droplets. But if there are very least amount of water vapor, then what is there to form water droplets with? So if you compare, take for example a desert. Desert is very dry and almost have no water droplets because as the sun goes up, it easily evaporates or makes water droplets or water vapor go up into the sky faster. It dries out the air. The air in the desert is drier and contains least amount of water droplets. And therefore, condensation in that place could probably take slower, or the rate of condensation in that place probably would take longer than if you have um, ocean, for example, which contains a lot of water vapor, or other areas where there are a lot of water bodies that will produce a lot of water vapor in the air. So I have this one example here, a hot coffee and a glass of water at room temperature. If you put a water glass above them, where do you think you will observe condensation appearing quickly or fast? It will be on the watch glass above the hot coffee because the hot coffee produces a lot of water vapor and therefore it has higher amount of water vapor in their surrounding air or the surrounding or that surrounds the watch glass. So if that happens, a lot of those water vapor will lose heat as they touch the cooler surface of the watch glass. So if there are a lot of water vapors, then a lot of water droplets will form. The faster the rate of condensation. Whereas here, if you have an equal, if this is room temperature, if the temperature is similar, the temperature of the surrounding air and the temperature of the glass or the watch glass are similar, then heat won't travel. We learned that heat travels from warmer air to cooler air. So if both have the same and equal amount of heat, then heat won't travel. Heat won't, or the water vapor won't be able to lose heat on the watch glass, even if they touch the watch glass, because they have the same temperature. Whereas here, the water vapor that the hot coffee is producing is warmer than the room temperature of the watch glass. So if that happens, then heat will travel. The warm water vapor coming out from the hot coffee will lose their heat as they touch the cooler surface of the watch glass, forming water droplets. So condensation happens again when there's a difference in the temperature, and second, when there's higher amount of water vapor around the area. Now, what did we learn today? Let's have a quick recap. First, we learned that condensation is a process of change from gaseous state to liquid state. Second, we also learned that when water vapor loses heat, will form water droplets. Third, warmer air condenses, not cold air, it's the warmer air and forms into water droplets. Fourth, the wider the temperature difference, the faster the rate of condensation. And last but not least, the greater the amount of water vapor in the air, the faster the rate of condensation. Thank you for listening. That's our lesson about condensation.